Hi guys, Mr. Johnny here. In this video we're gonna take apart this capacitor from the television that had the common mode choke all burnt up. First thing first, we take a sharp knife and we stab ourselves. In the process, not right now. I'm sure that will happen. Yeah. I'm cutting towards my thumb, so then we can take this cover off. We see that it's not bulged, really. It's pretty flat. It's actually optional to take this plastic off, but you just need to nibble it like this, then you can sort of unwrap it like a present. And you can see a nice aluminum can, which I might put to use. Now, again, because I told you that I might put this can to use, I want to utilize all the area, all the height, so I ain't gonna cut off here. That is kinda useless for our purposes of as well, so I'm gonna go and cut right here, right over here. I'm pretty sure that this crimp might cause some problems still, but put a little bit of sacrificial wood there. And we're just gonna apply pressure on the blade and roll it. Ooh, see the hole right there. By the way, when I cut through it, I heard a little fizzle, so there was some pressure inside. Not a whole lot, but it was under pressure. That's, by the way, the area where the seal is. The actual capacitor is here, under this groove. Focus here. You can see the guts. Oh, that's quite a rip-off. It's not packed full. Some capacitors are really tight. I mean, like, you have to pull it hard to get this roll out. Here it's loosey-goosey there. Kinda stinks, not very much so. You might wanna wear gloves doing this, but meh. You can see on this side there is something that looks like you know those boards, phenolic resin bonded paper kind of thing. That's kind of the same material. On the other side it is rubber-ish, because you can see how it deforms right there. Anyhow, so that's the actual capacitor. See, in the previous video I was talking about the separator. That's what this paper is all about. It's not the actual insulator. And we unroll it. That's a separator. See, right there. Oh, and we see some electrolyte. It's kind of wet here. Yeah, wear gloves if you're doing this. Do not be like me. But you can see have some grease stains on my hands because I was mucking around with a gearbox on a motorcycle. So I did not film that because first of all it's sort of an electronics channel, but I don't know. So that's a separator. Under it you can see the plate. Then another separator. See? Then if we take that off, which is kind of pesky because it's very thin. Here, I guess it's another layer right there of separator. It's a high voltage cap. And there is another foil. So, and this is to prevent it shorting out to the can. So you can see separator, actual electrode, plate, separator, separator, just so they don't touch each other. As you can see, they are soaked with electrolyte, and that acts as a plate, one of the plates, and that's the other plate. This plate is much thicker. You can probably see from this. It's very springy. Whether this is, you can hear. And this one, it's much thicker. And you may also... Did you hear that? I caught that on video. I totally did. This capacitor is still charged. You'll be able to see it even. I think you saw it. It was a genuine discharge. That's kind of nice. And see how this color of this plate is much different. Well, this one seems aluminum color. They're both aluminum, but this one is oxidized. And the oxide on this plate is what is an actual dielectric here, which separates the two plates. This just physically separates them. The aluminum oxide electrically separates those plates and creates the capacitor. So let me just unroll this cake. This one is a negative or positive, I'm kind of not sure. Which one did I rip off? See, this one darkened plate is connected to this one, which is does not have, you can see this one has kind of punched a little texture in there, and this one doesn't. You can see punched is negative right there. So you can actually take a polarity, understand what the polarity is without actual shrink wrap. So that makes this positive electrode, which is oxidized. It's not very tightly wound at all. Let me get this plate off. You can see that. You can actually cut yourself with this one, so be careful. I don't see any damage. You can see it's pretty long. Like, oh shit. Okay, this piece is about 40 centimeters it is. And the other one, or 53 actually, so 53 plus 40, so that's pretty much a meter, pretty much like 3 feet there. And the other one is similar. And as well, again, I don't see anything nasty on this. I would not say that it is dry, you know. It is quite squishy. I mean, like, I did not take apart the brand new capacitors because I'm too cheap to do that. Ugh, it's kind of noisy. But you guys seem to like the raw style of my videos. It's pretty much a pristine condition, there is no burn mark, so it was not shorted in some place. Why did it then... Yeah, the surface is like that all over the place. Not bad at all. And the actual separator does not have holes punched in it. Anyhow, so touching the phone with that, it's actually not, you can see, not very crummy, barely wet. I mean, like, they're electrolytics, but that doesn't mean that they're sloshing electrolyte there. So you can see what's inside the capacitor. Two plates, but the dielectric between the plates is the actual oxide there on the positive electrode. And this is between them to physically separate the plates from touching. Because when they touch, they might move, they might scrape the aluminum oxide off, and again, they should not be physically touching. First of all, if they do, they would not be able to form that oxide layer, because the way this thing is made, they make this roll up with two plates that look exactly like this. No, aluminum colored. Two aluminum colored plates, they roll up this nice roulette, and they assemble the capacitors and they apply the rated voltage, which forms an oxide layer on one of the plates, and the plate that is connected to the positive of the supply, and that's what this dark layer of this thing is. Being a total cheap as I am, I really wanted to utilize this thing for shielding, for electrostatic shielding of the switch, of the transformers in the switch mode power supplies. But the problem with that usually that is done, electrostatic shielding is done with a copper tape, copper foil. Copper is very easy to solder to, you know, and aluminum is not. I even mucked around with it, trying to plate the aluminum with zinc, with copper, with nickel. Everything failed. And especially this oxidized stuff is just pretty much goes in a trash right away. This you can kinda get away if you use aggressive flux, and you can kinda thin this surface a little bit, but it's still not very nice. Not a very nice experience. Actually, and to prove it even more, beeper mode, I'm gonna have this shiny aluminum here. I washed them in a sink, so you can see, and it is a smooth beep. I mean, like, here, let's get the part which I did not scratch. Stay there. See, it's not really. I'm just putting the weight of this probe there. Sounds kind of like a Geiger counter. That's why the separator is there, because just a kind of metal to this layer, oxide layer, it's still pretty much a short circuit. But if you separate it, so it's not a direct metal to metal contact, it isn't dielectric. Again, this one is, let's make it flat here. You can see Okay, actually, if I really want, I can utilize this foil again, make a paper capacitor or a plastic film capacitor. I did make some time ago a capacitor that was running out of memory on the phone. It used polyethylene film as a dielectric and aluminum foil as a plate. That was a high voltage capacitor. Thanks for watching. See ya.